Welcome all. Now we shall see the next example of material balance calculation. Material balances on a batch mixing process. So initially we shall read the problem carefully. So what is given in the problem? 2 methanol water mixture. Okay, 2 methanol water mixture are contained in separate flasks. That means 2 separate flasks are there, and each flask contain a mixture of methanol water. Okay, methanol water. The first mixture contains 40% weight by methanol. Okay, first mixture contain 40 weight percent methanol, and the second contain 70 weight percent methanol. Okay, the two flasks are there. One flask contain 40% weight methanol and second flask contain 70% weight methanol. Then if 200 gram of first mixture is combined with 150 gram of second, then what will be the mass and composition of the resulting mixture? Then what we do, what is given? 200 gram of first mixture is combined with the 150 gram of second mixture. Then what is been asked? Mass and composition of the resulting mixture. So initially what shall we have to do? We have to draw the flow chart. Okay, flow chart. So here is the flow chart. So you can say that this is one process where two separate flasks is combined. Okay, two separate flasks is combined here. Okay, so the first flask contains 200 gram of mixture, 200 gram of methanol water mixture, in which the constituent, that is methanol, is present as 40%. Okay, 40 weight percent by 40 weight percent methanol. So here what we have taken, instead of mass percent, what we have taken, or weight percent, we have taken mass fraction. Okay, mass fraction of methanol, in the first flask. Okay, in the first flask, which is actually 200 gram. Okay, this mixture is 200 gram. Okay, 200 gram, which contains 0.4 gram of methanol as its mass fraction. Okay, as its mass fraction. So remaining portion or remaining fraction would be water, which is about 0.6 gram. Okay, 0.6 gram water as the next fraction present in the 200 gram of water methanol mixture in the first flask. Similarly, it is given that the 150 gram of another flask, or 150 gram of flask containing 0.7 gram of or 0.7 gram of methanol as its mass fraction. Okay, mass fraction, while the remaining is water, that is 0.3 gram of water. Okay, so this is 150 gram and another flask having a mixture 200 gram. So these two flasks are combined in a unit. Suppose these two flasks are combined in a unit. So what is being asked? The resulting, okay, the resulting mass and the composition of the mixture. The resulting mass and composition of the mixture. Okay, so this resulting mixture, okay, the resulting mixture would be unknown to us. Okay, this resulting mixture is unknown to us. So we here would consider this as one of the unknown, as a variable, and it is indicated by Q over here. Okay, so Q is the resulting mixture. Okay, this Q is the resulting mixture, and this resulting mixture, okay, the mixture which has been resulted, or the mixture that we obtain, okay, the mixture that we obtain after combining two different flasks having 150 gram, one flask, and other flask having a mixture 200 gram. So these two are combined, and what we get is the resulting mixture, whose composition, okay, we have to identify. The resulting mixture is here unknown to us, so we have indicated here by a variable Q. Okay, Q gram. This resulting mixture would have certain composition of methanol as well as water. So suppose in terms of mass fraction, we would consider this would be X gram of methanol. Okay, X gram of methanol, as a mass fraction present in the resulting mixture. Okay, resulting mixture. So if we as we know that the mass fraction, okay, mass fraction, okay, whatever the mass fraction that is or the constituent in terms of its mass fraction, when we sum up, it always comes out to be equal to 1. Okay, so if we have held here that x is a mass fraction that is present in the resulting mixture, x gram of methanol is the mass fraction of methanol that is present in the resulting mixture, then 1 minus x, okay, 1 minus x would be the mass fraction of water present in the resulting mixture. Okay, so we know and we have already learned that whenever in terms of mass fraction, a stream may contain many constituents, and when we try to identify the mass fraction, then all this mass fraction of each of the constituent in the stream, when you sum up, okay, mass fraction of each of the constituent in a stream, when you sum up, it always comes out to be equal to 1. And therefore we are holding here that the mass fraction of methanol, okay, mass fraction of methanol as suppose x, then the 1 minus x, okay, 1 minus x would be the mass fraction of water that is present in the resulting mixture. Okay, 1 minus x is the mass fraction of resulting mass fraction of water present in the resulting mixture. So here what we have found out and what we have corrected here and what we have put in the flow chart is what is the data that is given. Okay, we have correctly put all the data, all the information on the flow chart. Okay, so how many unknowns are there? There are 3 unknowns. Okay, there are 3 unknowns. Now in order to make the material balance calculation for our convenience, what we have established that whenever we want to frame equation, that is whenever we want to frame equation, then the equation should carry only one variable. So this is the condition that we have thought of. Okay, so this condition must be fulfilled. Suppose a material balance calculation can be done on an entire process, or a material balance calculations can be done on a single unit. Okay, single unit. So it is here possible for us to find out the material balance, or to make the take the material balance calculation on entire process as well as on individual units. Okay, so material balance calculation can be done on entire process over here, or the material balance calculation can be done on unit like or a individual unit like methanol. Okay, methanol, or on water. Material balance calculation individually can be done. So first of all, there is an opportunity for us to think that what equation we can make of. So we will do a material balance calculation on entire process over here, because this is the mixture, this is the first mixture and this is another mixture. These two mixture enters and combines, and finally they result in a mixture, okay, whose composition vary, okay, whose composition actually varies. So we can say that the mass, okay, the mass of the input must be equal to the mass of the output. So here we will first make the material balance on entire process. Okay, on entire process. So here total mass balance we would calculate first, because we know onto our left hand side the units or the amount of amount that is entering into the system. Okay, amount that is entering into the system, they get combined and finally result in a mixture. Okay, so here we can say that we can calculate the total mass balance. So just calculate, to my left hand side there is 200 gram of mixture from one flask enter, and 150 gram of mixture enters and both they get combined. Okay, so left hand side, that is input side, is 200 gram of first mixture and 150 gram of another mixture, but we don't know how much is the resulting mixture. So how much is the resulting mixture? So resulting mixture comes out to be Q is equal to 350 gram. Okay, resulting mixture comes out to be 350 gram. So here we have we have made a calculations on entire process. Okay, so in this case there is a possibility, or you can make the calculations on individual unit also, as if you consider methanol balance. Okay, methanol balance. So methanol balance, as there are two stream, they are coming into the process and combine, and therefore these two units, okay, these two units, that these two streams have a known value, okay, but the outstream, okay, outstream is unknown to us. So there is only one variable which can be there in the equation. So I can say that there is a possibility, or we can have an opportunity either to go by the doing the material balance calculation on entire process, or individual unit can be taken into consideration for material balance calculation. So initially what we have done, we have made a total mass balance calculation. Okay, we have calculated a total mass balance calculation. Okay, so what we have got, Q is equal to 350, and now it is time we can make a material balance calculation on each individual unit. So first of all, we will make the material balance calculation on methanol. Okay, methanol. So methanol balance, okay, methanol balance you can perform over here. So the amount, okay, the amount of methanol, or the mass fraction of methanol multiplied by what we say the total mass total mass of a mixture. Okay, total mass of a mixture in the first class. Okay, in the first class, how this comes, 200 gram into 0.4. You know that there is one equation. That equation is mass fraction is equal to mass of that constituent. Okay, mass fraction is equal to equals to mass of that constituent divided by total mass of the stream. Okay, total mass of the stream. So total mass of the stream, or total mass of a mixture in a flour in the first class is 200 gram. Okay, 200 gram. So divided by, you know that we just want to calculate the mass of that particular constituent, that is methanol. So we have here two known quantities, that is the mass fraction we know and the total quantity we know, and therefore we have to find it out, the mass of a methanol. Okay, mass of a methanol in the in 200 gram. Okay, how much is the quantity of methanol present in the 200 gram of mixture. So you know that one formula we have used, and accordingly we have taken over here. Okay, so mass fraction is equal to mass of methanol divided by total mass. So total mass, you know, 200 gram, mass fraction, you know, 0.4. Okay, 0.4 of methanol, mass fraction of methanol is 0.4, and so we would get what mass of methanol present in 200 gram. Similarly, here you can also calculate the mass fraction of methanol, mass of a methanol in 150 gram of a mixture, that is in the second flask. Okay, second flask. Using the same equation, you can find it out, the exact or actual amount of methanol present in 150 gram of mixture. Okay, so these two terms, okay, these two terms with regards to methanol is present as a input. Okay, it is present as a input, and that is why it is taken to our left hand side. Okay, so this is our left hand side, 200 gram of methanol multiplied by its mass fraction 0.4, that comes out to be the amount of methanol present in the 200 gram, plus 150 gram of mixture multiplied by 0.7 gram of methanol, that is 0.7 gram of methanol, that is the mass fraction of methanol in 150 gram of methanol. So it comes out to be equal to mass of a methanol present in 150 gram of mixture. Okay, this is equated to right hand side. Okay, this is equated to right hand side. So initially we have through total mass balance calculated Q, the value of Q. Okay, value of Q. So in Q, that is in the resulting mixture, how much is the concentration, or how much is the amount of, or how much is the concentration of methanol present, that we want to identify. We know only Q, but we don't know how much is the fraction of methanol or composition of methanol that is present in Q or in resulting mixture. So similarly here also you can do the same calculation. total quantity multiplied by mass fraction, what you would get the mass of methanol present in the resulting mixture. Okay, total quantity, that is Q, multiplied by mass fraction of that particular constituent, we would get the mass of methanol present in the total quantity. So this is the equation. Okay, this is actually the equation. We know that Q, we have just find out Q value, it was 350. Okay, it was 350, and finally when you make the calculations, what we get is the X, that is the mass fraction of methanol. What we get, the mass fraction of methanol. So how much is the mass fraction? 0.529 gram. Okay, so we have calculated over here the mass fraction of methanol. Similarly, we can calculate the mass fraction of water, and finally we can reach to find it out that the left hand side, that is input, is equal to output. So here we will find out the water balance then. Okay, water balance, similarly you can make the calculations as what you have done for the methanol. So 200 gram or 200 gram of mixture multiplied by mass fraction of water in the mixture, what it gives? It gives the amount of water present in the 200 gram plus 150 gram of mixture multiplied by 0.3 gram of 0.3 gram of water, that is what we say mass fraction of water present in 150 gram of methanol. What it gives? It gives the mass of water present in 150 gram of mixture. So okay, this is equated to right hand side. So Q is the amount of, or the total or the resulting mixture multiplied by mass fraction of water. Okay, mass fraction of water present in the resulting mixture. What it gives? The amount of water present in the resulting mixture. So here we have taken. So we know that what earlier what we have calculated X. Okay, X. So put this value here, 1 minus X, suppose 1 minus X. So resulting water balance, okay, resulting water balance we can get. Okay, here we can get the result, that water balance, how much is the water balance? Okay, this is a water balance. So 165 gram. Okay, 165 gram of water is present to the left hand side as well as in the right hand side. So 165 gram of water in the left hand side, 165 gram of water in the right hand side. So here the input is equal to output with regards to water. Okay, with regards to water, so water is balanced. So if the water is balanced, then we can say that, we can conclude that if water is balanced, then methanol also get balanced, and the entire process, okay, the entire process is also balanced. Okay.